Hi, I'm Bruce, and welcome to my Colorado Mountain Labs. And welcome to part two of our little project to build this 0 to 30 volt, 5 amp constant voltage, constant current power supply. So the whole trick was we bought a power supply just to see what we thought of it because it was ridiculously cheap, running around $6. Provided a voltage and current readout, dual readout, to the hundredth of a volt, hundredth of an amp, and provided 5 amps at 30 volts, and it was constant voltage, so you controlled it either by voltage or by current. I was amazed and thought, how could they do this, and decided to give it a try. And I received the unit. It was all one little palm-sized unit consisting of two boards, a readout with a bottom board that contained all the regulators and such. You still needed to provide a source of voltage and current to it, but it then was able to control that voltage and control the current and provide the readouts. I was impressed with it. It worked. It worked fairly well. However, it wasn't easy to work with. It lacked many of the features that you would need, like outputs, a decent readout with a lens so you could see the digits better, knobs that you could deal with your hand instead of having to use a tiny screwdriver to go into a trim pot, and then all of the connections that had to be made with special jumpers and all of that, and you had all that spaghetti all over your desktop. So I thought, what am I going to do with this now? And I thought, I'm going to see if I can take it apart and use this as the basis for a CVCC power supply. And that's what this was all about. So anyway, once I had the unit mounted in the case, we used an old B&K 283 digital voltmeter case, which, believe me, if you look at part one, the original pictures, it was something to see. And we painted it up, cleaned it up, and remachined it, and have now turned it into a really nice little instrument. So I'm going to open this thing up. We're going to take a look inside, and I'll show you where the power supply and what changes I've made. Okay, we're removing the top, and we see the components on the inside of the case. So what changes have been made since last time? Well, let's take a look first. We installed the power unit, the power supply unit here. It has two outputs. One of them is 0 to 36, the other is 0 to 30. There are adjustment pots here and here. This adjustment pot is for the outlet I'm using, and then you have another one buried in this heatsink. And it takes in 110 volts and turns the AC into DC and provides up to 5 amps at 36 volts. But in order to get the AC in here, I needed a cord. So, and I also, if you're going to use a cord and have AC power, you need a fuse, you need a switch. So I have a switched outlet that I picked up on eBay for like $2. Nice unit. Built-in fuse holder, on-off switch, and then takes a standard computer type cable. So I was able to put that in. I grounded the ground lug to the chassis, and then was able to provide the 110 volts on these clip lead type wiring points, wiring connectors. Then out of it, there's a positive and a negative lead that goes and provides power to the CCCV buck. The power supply is not analog. It's a pulsed modulated type supply. So it does produce some hash. So in playing around with it, I found that I had a 4700 microfarad 35 volt capacitor in my box I hooked that to the outlet to try and smooth out some of the noise, some of the hash, and then brought that over to my CCCV buck. And then in order for me to get this switched outlet in here, I had to cut a hole in this rather substantial metal panel. And in order to do that, I didn't want to get all of the metal chips inside all of the components, so I removed everything out of the cabinet before I cut the hole. Since I had it out of the cabinet, I went ahead and doubled up on the wiring to all of the corners of the readout module from the base module. Did that because I suspected from the way that it was manufactured originally that they wanted a current and voltage to be brought between the two substantially. They had metal standoffs that conducted the power up there. I didn't want to have a voltage drop on my wires, especially when I started drawing high current, so I doubled up on everything. And I took the outlet and I put on a couple of ferrite core RFI reducers just to try and eliminate some of the noise, and I installed a 4700 microfarad 35 volt capacitor to across the outlet to remove some of the hash from this module, and it worked also. I was able to reduce the noise level by about half. So let's see, did I miss anything here? No, I think I've shown you all of the major changes. Let's move on to testing it, huh? Okay, well, we've got the unit supplied with power. We've turned it on in the back. You can see the readout is setting at 0. We're in the constant current mode where the amps knob here is really ruling the roost. The voltage is set so that if my amps allows it to, it'll go up to the full voltage, which in this case the 30 volt output of the power supply will produce about 28 volts in this unit. I could have raised it to 32 and gotten 30 out, and I might do that, but right now that's where we're at. And the output of the unit is going through a 10 ohm 50 watt 1% resistor that is inside this cooling box right now, where I have a fan that's running, and then I'm tapping off the 10 ohm 50 watt resistor and reading the voltage on it back here at on my HP voltmeter. So if I am putting voltage or getting voltage across a resistor from which I have current flow through, and the voltage that I'm getting across the resistor is 1 volt and the resistor is 10 ohms, then I must have 0.1 amps because I equals E over R. If I had 5 volts, I'd have 0.5 amps. If I had 10 volts across a 10 ohm resistor, I get 1 amp. So if I'm monitoring the voltage across that resistor, all I do is just read the voltage and divide by 10, and I've got my current, which I can compare to my my voltage and current readout up here. So let's go ahead and take this thing up. All right. Here is, if I very gently bring in 0.5. Okay, I've got a reading of 0.499, and I'm getting 0.05 amps showing on the ammeter. 0.499 divided by 10 would be 0.05, so we're correct. Voltage wise, we got 0.47, and I've got 0.49, so I'm about 0.02 of a volt off. I'm going to go ahead and raise this thing now to give ourselves 0.1 amps. All right, we've got 0.999, roughly a volt. I'm reading 0.98. I've got 0.1 amps, and so if I've got 1 volt, and I'm dividing by 10, then I've got 0.1 amps, and that's what I'm showing here. Let's go ahead and take her up to 5 volts, 0.5 amps. Okay, we've got 4.996, 5 volts. We're reading 5 volts now. And we have 0.49 amps. That would be about a hundredth of an amp low because we're really getting 0.5 amps. But let's go ahead and take her up. Current is still controlling everything. We'll take her up to 10 volts, which would be 1 amp. Okay, we've got 10.006. We're reading 10.0 volts on the readout, and we have 0.99 amps. I'm reading 10 volts over 10 ohms. We're getting an amp, so 0.99, 10, we're right there. We'll take her up even higher. Let's go to 15 volts. It'd be 1.5. All right, we got 15.009. I got 15.1 here. So we're about a tenth of a volt off. And we've got 1.4849 flashing a little bit. Should be reading 1.5, so we're within, I'd say about a hundredth of an amp. That's good. Let's take her up to 20. That's 20.01, 20.2. We got 1.98. We have 1.98 would be within 2 hundredths of 2 amps. And 2 amps is what we've got. And we're going to take her up all the way here, just see what we can do. And we're going to make it quick because my resistor is smelling hot. Alright, that's my maximum voltage until I increase my internal voltage. I'm reading 28.3. I've got 2.89 amps. I've got 28.85, and that would be 2.89 amps. So 2.89 right there. Current-wise, we're right on. Voltage-wise, we're maybe almost a half a volt off at this voltage. I'm going to take her down rather quickly. Oh yeah, that's hot. Okay, so I have a power supply that's capable of constant current or constant voltage if I allow the volts to take over. Like I can turn my current up, and I can turn my my voltage down, and the voltage will kick in and become the limiting factor. All right. There is a point where it has to decide whether it's being controlled by voltage or current. It goes a little mad when that happens, but you can get past it, like right there. All right, my voltage is now controlling it. I'm dialing down. I'm 13, 12, 11. I'll take her all the way down. And my lowest voltage, using the voltage control knob is about 1.25 volts. If I bring the current into effect, we can actually drag her all the way down to 0, which we started out with. So that's kind of interesting. Well, I had the thing all the way up, adjusted it for 30 volts, was getting 3 amps output, and noticed a couple of things. One thing was my voltmeter was able to read about 28 volts maximum, and after 28 volts it wouldn't read any higher. Yet my Hewlett-Packard back there was showing that we reached 30. And then as I was dialing back down, I blew a fuse. My new power adapter back there, and had to change the fuse. So 1 amp might be a little bit small. That's what I have fuse wise. If you're going to try and run this thing at maximum current for any period of time, probably 1 1/4, 1 1/2, somewhere in there is what I'd recommend. But since most of the time I'm going to run this thing in a lower range, the 1 amp is fine for me. We're back in service. Everything looks good. The voltmeter, the minimum voltage that I'm able to read on the voltmeter is about 0.3. Even though I've got adjustment range below 0.3, I can get 0.1, 0.2 as I read on my HP. But I don't start reading until I hit 0.3, and then apparently I quit reading at 28. So I think that's a product of the unit itself. It was outputting up to 30, and I was getting 3 amps out at 30 on a 10 ohm resistor. I may give it a try to see if I can get higher amperage, but right now, I'm going to keep her the way she is. So what have I achieved with this? Well, I started out by just buying a really inexpensive unit for constant voltage, constant current, a buck, I think they call it. The 2 dials, each 10K pots, multi-turn with the knobs, about $3 a piece, roughly. So $6 in that. It was roughly $13 for the power supply that's internal to it. I had maybe $2 that I paid for that cord adapter unit with the internal fuse and switch. So what do we got? 2, 15, 6 would be 21, and 6 more would be $27. Oh, maybe throw in another couple of dollars for the terminals. So for under $30, I've got myself this nice power unit. And it works. It looks great. I am very, very pleased with it. I'll let you look at the back side here. Turned out very nice. Switch, fuse, cord adapter. Case is grounded. Nice unit. All right, thanks for listening. Bye.